Okay, so today we're going to be talking about translation, and unfortunately, again, I don't have a tool in which I can draw with, so we're just going to be following my mouse again like last time. So basically, after mRNA has moved out of the nucleus, it's going to go through a process which is called translation, and this is where the mRNA goes into cytoplasm and goes to a ribosome. The messenger RNA will either go to a free-floating ribosome or it will move into the rough ER depending on if it's going to stay in or out of the cell. And then the mRNA is going to be translated in the ribosome for future functions. So as you can see here, it is in a ribosome. But again, the mRNA is going to choose from one of the two types of ribosomes, which is either free-floating, which means it's going to be staying in the cell, or it's going to go in the ref ER, which means it's going to be going out of the cell, and it'll shoot out, then becomes a ligand if it's in the ref ER, and then it'll become a ligand, and the whole process starts all over with transcription and translation again. So, in the ribosome, as you can see here, all the things that are going to be going on with the mRNA in the ribosome and it being translated, it's going to read the mRNA from a 5 to 3, as you can see right here. And then this ribosome is made out of rRNA with some proteins, and then we have our mRNA right in it. So it's going to read it, and after it reads it through, what's going to happen is we're going to have tRNA, which is these things right here. As you can see, there are several right here, right here, right here, right here, right here, and some attached. So the tRNA has 3 base pairs, which are these 3 things all attached to it at the top. All these, has 3 base pairs called anticodons with an amino acid at the top. So everything that's on these tRNAs right here. And then as you can see, as this says, tRNA it's carrying the amino acids. And so these are the 3 base pairs, or let me show you right here. These are the 3 base pairs, as it says, the anticodons, and right here is the amino acid that it's carrying. So here's another one, and then all at the bottom, along with the base pairs, the anticodons. So the tRNA will float over to the ribosome, as you can see, these are all doing here. They're going to float to the ribosome and lock on to the mRNA. So as you can see, these 3 have already done and locked on right here. And it locks onto the mRNA strand that builds, or all of this is going to build our protein with these amino acids at the bottom. So it's going to lock on, and it is now building the protein we need, or the specific protein we need, as I was talking about in transcription. So the amino acids, because as we know, proteins are made up of amino acids. So this down here is what we're going to be, or what's going to be making our proteins. And then these amino acids are also monomers. And then they're going to be connected up here through peptide bonds, which is NH2 to COOH. And then the polypeptide, or it's called polypeptide protein bonds, is what's going to be made up after that. So after all of the tRNAs have been locked on and everything is attached, after it has been done reading through, the proteins are going to then become one, or the amino acids are going to then become one long protein shape, and it's going to be specific to a certain task because of the code that we have made through transcription and with our tRNAs and with the amino acids that are locked in the bottom right here. So just for an example of a protein that is made up after this process, if you can see right here, this chain like of the amino acids that I pointed out right here at the bottom of the screen, or at the bottom along with the tRNAs, that's all these things connected together that then become our protein for the specific task that we need.